Hi everyone, and thank you for joining the December 2025 VMware TAM customer webinar. This webinar is organised by the VMware TAM organisation to provide our customers the opportunity to interact with great speakers about content that will help them get the full benefit from their VMware software. Before we get into today's content, there are just a couple of basic announcements. Our next TAM customer webinar will be in the new year on January 15th, where we'll be going through the VCF Operations Management Pack Builder and a brand new vCommunity Management Pack. Your interaction during this webinar is important, so please make use of the Q&A feature of Zoom to ask your questions. If we're unable to answer your question during this webinar, please be sure to reach out to your TAM and ask them to follow up. At the end of today's session, you'll be prompted to fill out a simple 2-question survey related to the value you received from the session and any topic suggestions for future sessions. Your completion of this survey is a really valuable gift back to us, and we'd really appreciate if you could take the time to complete that. And lastly, this webinar is being recorded, and your TAM can make the recording link available to you shortly after this session. After a few months, the recording will be publicly available on the VMware TAM Services YouTube channel. And so that brings us to today's speakers and topic. It's my pleasure to introduce Varun Santosh and Dimitri Desmidt from our VCF Product Marketing Engineering team, and they're going to be talking to us about VCF networking for the private cloud. So over to you, Varun.
Thank you, Amy, for that introduction. And hello, everyone. Welcome. And thank you again for joining us today. My name is Varun Santosh. I'm on the VMware Cloud Foundation team focusing on networking. And I have with me my colleague and co-speaker today, Dimitri, who is on the VCF technical marketing team, also focusing on networking. As the title suggests, in the session today, we will cover some of the basics of networking in VMware Cloud Foundation, why you should turn on VCF networking in your environments, and how VCF networking simplifies connectivity for VCF workloads. Dimitri also has a few demos lined up to show you how you can enable some of these capabilities in vCenter as well as VCF automation. Let's go over the agenda real quick. We'll start by covering the benefits of VCF networking and how it is purpose-built for workloads running on VCF. Dimitri will then go into a little more detail on physical networking and virtual networking, how they are different, and how network virtualization simplifies not just the network architecture, but it also simplifies operations and automation in VCF. We'll then dive deeper into one of the key technical differentiation in VCF networking, which is VPCs or virtual private clouds. And then we'll wrap up with some resources you can use to get more familiar with VCF networking. Okay, so with that, let's get started. Okay, so those of you who have closely followed the evolution of VMware Cloud Foundation or VCF, you've heard a lot about the modern private cloud. The idea here is to offer the best of both worlds, delivering all the advantages of public cloud and all the benefits of the data center. So the public cloud, of course, offers great agility, scalability, automation, and self-serviceability. And with the data center, of course, you get more control, right? So more cost control, security, better resilience, sovereignty over your data and infrastructure resources. But the reality is that achieving all of these benefits in one single environment is really challenging, right? And there are several reasons for that. There are too many manual workflows involved, so automation is really complex to achieve across the entire infrastructure in a consistent way. On the operations side, operationally, you often have to deal with multiple interfaces, so multiple UIs, consoles, CLIs, APIs. You might also have separate platforms for different kind of workloads, so VMs, containers, microservices, emerging AI workloads. So you might be dealing with multiple platforms. And finally, there are operational challenges on how do you efficiently scale your infrastructure resources to support growth, and how do you create a really resilient private cloud across multiple tenants, multiple sites, and multiple regions. Now, these challenges are addressed in the public cloud using VPCs or virtual private clouds. And we in VCF want to use the same constructs in the private cloud to simplify your operations. There are three foundational capabilities that VPCs enable. There's enabling self-service access to cloud resources so that application teams can deploy their applications faster and have access to these network services in a self-service manner. VPCs also make it easier for you to create and maintain isolation between different applications and different environments across the private cloud. And then they make consistency and scale much easier to achieve. And we'll double click into each one of these in a little more details. But these are the principles we have used to develop network services in VMware Cloud Foundation to really enable that cloud operating model. Okay, now let's take a closer look at these foundational aspects of a private cloud, starting with self-service access. Now, the underlying idea with self-service is you're enabling your platform teams or your application teams, your DevOps teams to include the connectivity and the security that they need when they're deploying their applications, right? So they need not be experts in networking or security to be able to do this with VPCs. How does this work? You create a VPC, you set quotas and limits on what can happen within those VPCs, what can an end user deploy, and then you allow self-service access to those VPC resources so that the application team or the platform team can deploy the applications themselves along with the networking and security services that they need. Now, this, of course, is very different from the traditional way of doing infrastructure, which is not very cloud-like, right? So you start by identifying the host on which your workloads go or clusters. You create your VLANs for connectivity. You might have to create routing or firewall rules. You'll have to add load balancers into the equation to make this entire environment work. And this just requires a lot of complex ticketing between different teams and complex infrastructure provisioning to make sure that configurations are consistent across different layers of infrastructure. With VPCs, we turn this around, right? By utilizing VPCs, you are eliminating that ticketing process. You're eliminating the involvement of a lot of different teams during the application deployment process. You're automating the manual part of provisioning using this VPC workflow. Now, of course, this has a couple of different benefits. You can deploy your applications faster, which obviously increases your developer productivity, right? They get self-service access to this isolated VPC environment so that they can deploy their applications and the connectivity, so the subnets that they need, any firewall ruling that they might want to deploy for their workloads, independent of the infrastructure, right? But you, as the VCF admin or the overall admin, still get to retain control, right? So you can still define policies at infrastructure level or at an organization wide level, but you don't need to get involved in every single application deployment process, right? So that way it lowers the operational overhead on IT teams and cloud admins, and you can really achieve scale and compliance without going through a complex ticketing process. Okay, and I think it's time for our first demo of VPCs and VCF automation. So I'll hand it over to you, Dimitri.
Yes, thank you. Let me share my screen. Here we go. You should see my screen, correct?
Yes.
Okay, so as Varun mentioned, we're talking here about the VCF capability of providing a private cloud similar to a public cloud where the tenant, the app team, or the end customer has full autonomy to deploy and manage its application, so compute, storage, and network. So it doesn't need to open any ticket. So of course, it doesn't, the end user here, I'm the admin of the org one, so I could be the Pepsi customer or the Coke customer or the app team of my company for the finance application, whatever. I have access to this, to VCF automation. I don't have access to the backend vCenter, to the backend NSX, which is providing the network virtualization. I just have access to the VCFA. This portal that has been given to me by VCF for the deployment of my application, as Varun mentioned, has some quotas. So I have some CPU limit, memory limit, storage limit. And here I'm completely free to deploy my applications. So compute, storage, network. I can create my VMs here. I can even create containers. I can create my network with some load balancer. Okay. Um, all that manually via click, 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 or via API, or with the ability, with also the concept of blueprint. Like here, I have a two-tier deployment app blueprint with a couple of web tier front-ended by a load balancer. So end users access my web tier through the is load balanced by the load balancer to access the front-end web tier. The web tier can talk to the DB tier. I have the YAML output of this whole application on the right if I want to modify it. So I can create blueprint, or this blueprint can be published as a catalog, which is here. So as a developer, I can also simply in one click deploy a full application, compute, storage, network, like here. I will deploy that basic two-tier application. I give it a name, maybe not delete, but test one, whatever. I have some in the blueprint. I created some fields to make it a little bit more flexible, like a name, like in which new network this application will be deployed for the VMs, what username, password they will have, and yeah, I can in one click deploy that application. And in a couple of minutes, that application will be deployed in the backend of VCF for compute and storage, so in this vCenter, and the network will be with the load balancer, will be in the network component NSX, but I don't need to know any of that. Again, it will take a couple of minutes. So if I go here, I can see where it is, or because I don't want to wait for a couple of minutes, I deployed this one here. So we can see that application was deployed. I don't know why you can see it's live. Was deployed in the past. Man, my lab is overwhelmed. And if I go on the VIP on the LB, I can see. Oops, sorry. I can see the IP of the load balancer that has been deployed automatically from my blueprint, published in the catalog. So if I go here, yes, I'm load balanced to my front-end web server .4. The front-end web server can talk to the DB, the backend DB .3. And if I refresh, I'm load balanced to 5 and 4 and 5. Again, it's a very basic application, but it's just to give you a quick presentation live on how this can be simply accomplished in a fully automated way through VCF automation for the app team, for the customer and customers. So to have a private cloud similar to a public cloud without giving them access to the backend components. Yeah, Varun, I give it back to you.
Thanks, Dimitri. Let me bring up the slide again. Great. Um, So now let's take a closer look at the second foundational aspect of VPCs and private cloud, which is isolation. Now, isolation, of course, is critical to it helps to maintain compliance while moving fast and provisioning things fast. So let's take this example where you have some services running in your environment and you have your production workloads already deployed. Your application team comes to you and says they want to deploy and test, say, a new LLM application, right? So in this example, you may not want this application to have access to production or to your different data sources within the organization. And in a traditional infrastructure and traditional way of doing networking and security, implementing this is quite complex, right? So you'll have to uh, select the right cluster to deploy this new LLM application on. You need to configure VLANs and you need to configure firewall policies and make sure that the operations and configuration is synced across all those different layers in the network. Now, with VPCs in VCF networking, all you need to achieve isolation between different environments and different applications is to create different VPCs and put the right workloads in the right VPC. So in this example, for example, the cloud admin can create a new VPC for the application, and you do not need to involve multiple teams every single time, and you do not need to synchronize configuration across your networking layer, your security, your load balancing services across multiple physical appliances, right? So VPCs really simplify the workflow for creating segmentation between those different workloads and different application environments. I think we have our
Yeah.
second mode, which is VPCs in vCenter.
So this one is a very quick demo because we'll go deeper into VPC in vCenter. So previously we talked about the component VCF automation when you want to give like a public cloud experience to your app team or to your customers without giving them access to the backend, to the vCenter, to the NSX, to the different components. Here, let's say we're talking about the case where I am the vCenter admin and you're not ready to go through a true, fully public cloud experience, but you still want to manage and deploy and manage and operate your application through vCenter. You're the vCenter admin. And that's VCF 9, so that's vCenter 9. And the look and feel is very, very similar. So you have your different VMs. Here I have an application finance, an application marketing. But what is new is if I want, as the vCenter admin, to deploy an application in new networks, in the old days, I would open a ticket to ask for the network team to create my new subnet, my new default gateway, maybe some NAT if my DB database is in a private network. And after a couple of days, I will go into vCenter and create a new DVPG VLAN to map what the physical network team created for that subnet, that default gateway. So here now in vCenter 9, which is part of VCF 9, I have something new, which is VPC, which you can see here. You don't see that if you don't have VCF 9, vCenter 9. And directly here as a vCenter admin, I can create my network for my new application, my new network for my new application in a fully autonomous way, in a very simple way. And how simple is it? I already created a VPC finance and the web tier subnet and the DB tier subnet. You can visually see here. But to create a new one for a new application, I can create here. Let's call it test 2. For the private subnet, it asking me for a block of IP address. And this, I don't need to involve the network team because it's completely within my network bubble, my VPC. We'll talk about that in a few minutes. So yeah, I create that for my new VPC bubble. And in a couple of seconds, again, I do it live and in a lab that is overwhelmed, so it's a little bit slower than usual. I have created my VPC bubble, and from here, I can create a new subnet. And here, if I make it public, I don't know what subnet is available within my company um, for a new subnet that is reachable within my company. But we'll discuss that later. Um, I don't need to know. It will be auto-allocated because at the installation of VCF, a block of IP address reserved for the VCF is defined. And yeah, I don't know what subnet to create, well, to use, but I know I will have just a couple of VMs, so 16 IPs is enough. I need DHCP, boom, in one click, I created my DHCP server. And here we go in one click, in yeah, a couple of clicks to be fully honest, accurate. Then I have created my network bubble isolated from the VPC bubble network for my finance application. Here I created a new bubble with a new subnet that is given to me. It's 3030 slash dot 32 slash 28 with a default gateway already created, with the DHCP already created. And that subnet is advertised to the physical world. So if I plug VMs on that subnet, they will have an IP through DHCP in that subnet, and my external clients, like this Windows box, Windows client will outside will be able to access my applications. Okay, that's a quick introduction on VPC in vCenter, available from vCenter 9, VCF 9. We'll go deeper in the explanations in a couple of minutes.
Thanks, Dimitri. And hopefully that gives you a sense for the different flexible ways in which you can deploy VPCs and also different ways in which you can consume network services, either from vCenter, from VCF automation, or of course, you can use APIs as well. Um, the final pillar that I'll touch on really quick is scale and resiliency. Now, in VMware Cloud Foundation, VPCs are built on top of virtual networking. And it is virtual networking that really enables the scale and resiliency in the private cloud, right? So if I start with capacity management, for example, it allows your workloads to move across servers, across racks, across different sites, and also across any network fabric or topology that you might have in your environment. And a often common use case is consolidation or expansion of your VCF workload domains. For example, if you have an M&A and you have different network topologies or network fabrics in those two sites or data centers, it makes it really easy to either consolidate or stretch your network across multiple VCF domains. It also simplifies and speeds up the disaster recovery process. So there are no networking changes, so no IP address changes when there is a disaster recovery event. There are no firewall rules to migrate to a secondary site. All that happens automatically. The rules move with the workload when you want to move them during a disaster recovery event. And then finally, multi-region, multi-site deployments, right? So what virtual networking really enables scale by making multi-site, multi-region configuration, visibility, and troubleshooting easier. And we'll dive a little bit deeper into each of these aspects. I think, Dimitri,
Yeah,
it's your turn.
if you can, yeah, replace. Here we go. So what we wanted to do, because we have a lot of time in this session, we have 1 hour and a half. So we wanted to go a little bit deeper on how it works and why all the use cases presented by Varun, like workload mobility, like DR, requires network virtualization because workload mobility is more than compute and storage. When you move a VM from Paris to London, I mean, you need to move definitely the computer storage, but you need to move the network, which is attached to that workload as well. Same thing for the DR. So, yeah, the networking is a key element as important as compute and storage in any cloud and in your private cloud if you want to build a private cloud or have a private cloud. So let's focus now on especially the network component, the network piece of the VCF private cloud. And for that, I'll start with the comparison between network physical and logical when you have VCF networking and the benefits you have out of making your network for your applications in VCF networking. So a little bit of history or basic and basic networking. When you have your VMs inside your ESX, you can deploy those VMs on a DVPG VDS port group VLAN, and let's say VLAN 10, where you have physically the network for that VLAN 10 in the physical fabric. And that VLAN 10 is configured in your physical fabric on your top of the rack. And life is good. You can move VMs from an ESX to another ESX, and you have communication between your VMs in the same subnet, like .2 can talk to .3, even if they are on different ESX. Life is good. But now if you expand your data center and you have multiple racks, multiple rows of racks, and your fabric becomes bigger, you will have different VLAN, different subnet for each rack or for each row of racks. And now you cannot vMotion, you cannot move or deploy a VM in that ESX in the rack number 2 because that network 10 does not exist in your IP fabric, in your data center, on this rack there. So now you have your application that is isolated only in rack 1. Now, workaround that has been there for years is to create a logical network, and VMware with NSX provided that capability where you create a logical network, a virtual network that is your subnet, let's say 100, and now you can have VMs anywhere in your data center, even if your physical fabric doesn't have the VLAN stretched all over your physical fabric, your data center. And how does that work? I mean, you have on ESX a new IP address. So you have the IP address for your management, the IP address for your vMotion, the IP address for your vSAN, and you have another IP address. It's called TEP, tunnel endpoint. And when the VM 100.0.0.11 wants to talk to the VM 100.0.0.12 that is in another part of your data center, then that traffic will be encapsulated by the ESX IP address 10.0.0.7 talking to the ESX IP address 20.0.0.11. So the physical fabric, your switches, your routers in your data center do not see the IP 100. They don't need to see it. They don't need to know about it. They don't need to route it. They have no knowledge of this. They just see IP 10.7 talking to 20.11, and this they know. And the L2, that's why we call it L2 over L3. Your VMs on the same subnet can talk on a routed fabric. Here we go. And now your VM can even move, or new VMs can be deployed in the subnet 100 anywhere in your data center, or even data centers. It could be between Paris and London, for instance, or Paris and San Francisco. Okay, so that's how it works with network virtualization on VMware. And this gives you cool benefits like VM mobility, Varun talked about, because now you can have your applications anywhere, and not in silo where the blue application is in rack 1, the green application in rack 2, the purple application in rack 3. They can really be anywhere. And that will free also some resources because now you can condense your existing ESX and have a better return on investment instead of having them siloed. And you can do also cross data centers, as I discussed. Even the very same subnet, the very same application blue, can be spread across locations like Paris and London for VM mobility or disaster recovery. Now, one word I wanted to highlight, network virtualization or overlay. This is an overlay we do here. Exists also in physical fabric. You can do that on the Cisco you love, on the Arista you love, on any physical fabric you love. Overlay in physical fabric has been available for years and works great, to be honest. So how do we compare overlay on the physical fabric, sorry for that, versus an overlay done by VMware starting on the ESX? Because both are overlays. So why doing this one versus that one, or what are the benefits to do one versus the other? Here, when you do the overlay on the physical fabric, you still have VLAN configured on ESX. And you have your tunnels starting on the top of the rack, on your physical switch. Where here, the tunnel starts on the ESX. But does that really matter? What does it change? So let's go through the configuration when you use a physical fabric. So you will go on your, again, the Cisco, the Arista, the Dell, whatever fabric you love, and you will configure VLAN X everywhere on all your different switches you have in your fabric, and you will configure a VNI Y, that is your VXLAN Y, and you will map VLAN X with VNI Y, your logical network VXLAN with the physical VLAN X. And you will go on vCenter, and after finishing the physical fabric configuration, you will go on vCenter and configure your DVPG port group VLAN X on your vCenter, and you will attach your VMs on that DVPG VLAN X, where the VLAN X will be encapsulated through the L3 fabric through the VXLAN Y. So 2 points of configuration to deploy your application versus on NSX or on VCF with VCF networking offered by the component NSX. You just go on NSX. And now actually you can, as we briefly see before, you can even do it on vCenter UI API. You configure your NSX subnet and you attach your VMs on it and you don't touch the physical fabric. There is not a single configuration specifically done on the physical fabric. You don't touch it when you create new networks for your new applications. So that's the big difference. But it's not the only big difference. Here we talked about creating L2, a logical network L2, so a subnet that will stretch across your different racks in your data center. But network is more than L2. It's also a default gateway, a routing. It's also NAT. It's also VPN. It's also load balancing. It's also DHCP. And also analytics. And maybe also security with firewalling, with IDS, IPS. When you do VXLAN on your physical fabric, which is good. I mean, it's a very popular deployment. You should definitely do it. And VCF networking, so overlay on NSX can run on a physical fabric running also overlay VXLAN, and it's a great combination. It's not one or the other, but the applications, when the applications are plugged onto an NSX or VCF networking overlay, that gives you all simplicity as we discussed in the previous slide, but also all those network and security services on top where your physical fabric overlay cannot give you that. And all that, to finish, can be configured centrally from a single API. So what does that mean when you deploy a two-tier application? And I just realized I need to speed up. When you deploy an application like a two-tier application, your web tier in a subnet blue and your app tier in a subnet green with a default gateway blue, default gateway green with maybe some NAT, maybe some load balancing and so on and so forth. When you do it without VCF networking, you will configure your subnet in your physical fabric, creating the VLAN, creating the VXLAN for each VLAN on the physical fabric, and the DVPG on the vCenter. Then you will configure all those different extra elements in your physical fabric, your routers to configure the default gateway, your analytics, your VPN, your firewall on your Palo Alto, Fortinet, whatever you like, your load balancer on your i5, on your Netscaler, whatever you like. So you have all those endpoints to configure, to wire them. It's not always easy to do a chain to go through all those services. And so that most of the time, if not all the time, is done. It's offered by is done by tickets. The vCenter or the application admin will create a ticket for the network team to do the configuration of 1 and 2 and 3 and 4. It's multiple configuration point as discussed, the steering as discussed, and also automation. All those different points can be orchestrated, can be automated. F5, Fortinet, Cisco, Arista, and so on and so forth. They offer API, they offer automation, but it's not elasticity. When you have your, I don't know, it's not to pick up on Palo Alto, but when you have your firewall with the box, an appliance X that can do so much traffic, so much load, and your data center increase and you need more, then you need to replace this physical box by another bigger physical box. And that's not always easy. It's always through outage. And so, yeah, it's not elasticity where on the other side, all those services are done in the logical space, in the virtual space, and making those it's a central point of configuration. And it's elastic. You can easily scale up, scale down all those services. And all that is done without touching again the physical fabric. Physical fabric is needed. You need a reliable, performant physical fabric. So your switches and your routers are needed, definitely, because traffic will go through between ESX, will go from ESX to the outside world. So the physical fabric is important and must be reliable and performant. But just to do switching and routing of the virtual network created in the logical space in VCF and in the component NSX. And if you summarize, I mean, if you do it in the physical world, it will take, we've done multiple surveys with customers. I mean, we're not talking about hours or days, but weeks because of all of those bullet points. Multiple teams are involved and so on and so forth. And versus just seconds. Okay, I need to speed up. One last point on this, and then we'll do more demos again. All that can be done network virtualization in VCF through click, but also through automation and whatever automation language you like, REST API, Terraform, CLI, Python. I mean, all those can consume VCF network virtualization. All, as I briefly showed you in the first demo, can be done if you don't have expertise in those languages, can be done through VCF automation, click, or with Blueprint, as I showed you briefly before. And you have all those use cases we talked about, disaster recovery, VM mobility, and multi-site. And those are only possible if you have compute and storage virtualization, but also only possible if you have network virtualization. Okay, so one last point. We had a lot of customers who did not implement network virtualization, VCF networking on day one, and that's fine. So I just want to highlight one point. If you have an application running in your ESX, in your vCenter today, and obviously they are on physical VLAN and maybe on VXLAN in the physical fabric. So you have your VLAN blue mapped to the VXLAN, physical VXLAN blue, and that's perfectly fine. You don't have to touch and migrate or trash and redo this application. It can completely coexist with network virtualization done in VCF networking in the component NSX for new applications. And those old applications remain with the network services, switching, routing, firewalling, load balancing in the physical world. Maybe at some point you want to migrate them into the logical world, but you don't have to. And new applications can be deployed much faster. The blue application has been deployed slowly and painfully, I don't know, but slowly, definitely. So it's already done, so you don't need to change it. But new applications can be green applications can be deployed much faster and much more easily, definitely, with VCF networking using the same infrastructure, using the same ESX, vCenter, and so on. Okay. So I'm late, so I'll go super fast on this. VCF plus virtual networking, that's really what gives you a public cloud-like experience, but in your private data center, breaking down the silos of the network team, the compute team, the storage team, and so on and so forth. Centralized configuration of all the services you need, compute, storage, network. Simplifies also the scale because you have elasticity because it's virtualized, and speed up the deployment. Here we go. Feel free to ask
Dimitri?
questions. Yeah. Oh, there is a question. Okay.
Yeah, before we move on, quick question from Percy. So, uh, curious how NSX works with physical bare metal servers or
Yep.
non-ESX
Okay.
workloads. Maybe you can touch on the EVPN announcement as well.
That's not really related. Oh, yeah, it could be related with the EVPN, but so you have your physical server that is on physical VLAN connected to your physical switch, and you want that physical server to talk to VMs that are, or to applications that are in the logical space, whatever if it's VMs or whatever if it's containers. And if you want that physical server to talk to those applications, VM containers in the logical space, VCF networking, NSX logical space, and they do not need to be in in any of the logical space subnets, then it's just routed. And like an external client wants to talk to an application in VCF networking networks. It's routed and life is good. Now, if the physical server needs to be in the very same subnet as a workload, a VM on vCenter in NSX logical network, VCF networking NSX logical network, that's also possible. It's done through what I was calling here the bridge to VLAN. So yeah, it's possible, and the default gateway won't be your physical router anymore, but will be the NSX logical router, distributed logical router. So it's also both are possible. The virtual networks are for any compute, whatever if it's VMs, containers, or physical servers. And yeah, physical servers can have L2 or can have L3. Okay, I hope that replies. Now I want, what time is it? We still have 45 minutes, so not bad at all. Let's what we wanted to do, because again we have a long session, do a deeper dive on an enhancement that is in VCF 9.0 and the compute component vCenter that is now VPC aware. So want to do a deeper dive on VPC. Oh, I see another question. That's cool. Is the scope of IP mobility the VCF domain? Will this work if we have multiple VCF domain? Yes. So um, the virtual network can be. So I don't have a slide for that, but if you give me a minute, I'll give you another deck. I like questions, so thanks for asking those. And I'll show another deck if I can do it quick. And if not, I forgot if it's in this deck or not. Yes. So, okay, you have to speak VCF here. I won't explain VCF and workload domain here. Why I cannot do full play from custom shows and shoot? Why it doesn't? Anyway, that's fine. Oops, that's not what I want. It's that slide. So um, you have in VCF, you have what we call domains. So you have the management workload domain where you have all the components of VCF. So VCF ops, VCFA, vCenter, and NSX. Okay, all the components for the management of VCF. And then you can deploy multiple workload domains to host your applications, your different applications. And you can have only one workload domain, or you can have multiple workload domains if you're so big, or if you want to have dedicated workload domains, so dedicated ESX for different organizations, customers, whatever. So when you create a workload domain, like here, the blue workload domain, you can have a dedicated vCenter NSX for this blue workload domain and another workload domain purple with its dedicated vCenter NSX. And in that case, each network bubble, each logical network, I like to call it network bubble, will be available only in the blue for the blue network bubble and only in the purple workload domain vCenter for the purple network bubbles. And so you cannot vMotion, you cannot create compute blue a little bit in the vCenter blue and a little bit in the vCenter purple. However, you can do that. I don't know why I made it gray, but you can have workload domains blue and purple sharing the same NSX component. And in that case, your network bubble is stretched, is available within both blue and purple workload domains. And then you can deploy for a specific application this VM here in the vCenter workload domain blue, and this VM here on the very same subnet in the vCenter workload domain purple, or vMotion them, cross vCenter vMotion them, or have DR and so on and so forth. Yeah, I hope that replies to your question. And yeah, please bring questions. It makes the this is better for you and more live for me. Okay, I hope that answered the question. Yeah. So now let's go deeper in VPC, which is new in VCF 9, vCenter 9. So VPC is really like a network bubble. I like to call it a network bubble. And you will have your compute, your workload, your VMs, your containers in that network bubble. And of course, you can create multiple VPCs. And to create a network bubble, a VPC, you can do it through UI, click, 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 and you can create subnet, click, 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 and that will create subnet. Or you can use automation, PowerShell, Python, Terraform, VCFA to create subnets inside this network bubble blue. And network bubble, again, it's not like a physical fabric, a physical switches and routers where you do your VXLAN. VXLAN is just giving you a switch, a subnet, and that's it. a network bubble is more than this. Your applications need more than a subnet. It needs a default gateway. It needs maybe a DHCP server. It needs connectivity, so advertising connectivity to the outside world. Advertising that subnet to the outside world, so the outside world can reach those new subnets. VXLAN in the physical fabric is just a piece of that. And NSX, VCF networking, is creating a network bubble, which is, yes, the subnet, but also the default gateway, the DHCP server, and all that. And something important I briefly talked about before, it the IP the subnet here comes from IP blocks. And if you make it public, if you create a public subnet, this IP block this subnet comes from an IP block that has been created at the installation of VCF. So the network admins were involved at the deployment of VCF because they need to tell you at the deployment of the VCF at the beginning what IP block they reserved to be consumed later by VCF for the VPC, future VPC networks. So they gave you an external IP block available for you to consume, to use. Okay, so talking about that, how does VPC talk to the physical world, or the physical world talk to the VPC, to applications running in the VPC network bubble? We have three kinds of networks you can create. I call it t-shirt size options. And depending on what option you choose, you will have people outside external people able to talk to your subnet or not. For instance, if you have a web tier, DB tier, you want people from the outside world to talk to the web tier, but not the DB tier. Only the web tier can talk to the DB tier. So you can do that using a type of VPC subnet. On top of that, if you want, with an add-on, you can use our security components, firewalling, IDS, IPS, if you want to also secure the different compute running on networks. Like the web tier is on a public subnet, so external world can access it, but maybe you still want to control, like I want to allow only HTTPS and maybe add some IDS, IPS. This is through vDefend add-on. Okay, back to the networking. So you have the three subnets option. So you can make a subnet private. And in that case, when all the VMs attached to that private subnet, nobody outside of the VMs connected to the VPC subnets can talk to it. So everything else cannot talk to it. By default, you don't need a firewall or whatever for that. It's just not advertised, so nobody can talk to it, other VPCs or external world. And this IP subnet comes from the IP block private. We'll talk about that in the demo in a minute. Then you can create another type of subnet in your VPC blue, network bubble blue, private transit gateway subnet. What does that mean? This one means VMs connected to that subnet, private transit gateway, other VMs in the VPC network bubble blue can reach it, but also other VPCs, VMs in other VPCs can talk to it. There is IP connectivity between those, but not the outside world. The outside world cannot talk to those VMs. This subnet is not advertised to the physical world, so the physical world cannot talk to it. No need for firewall because there is no IP connectivity. This subnet is not advertised to the physical world. And this subnet comes from the block, private transit gateway block. And finally, the public subnet. So if you create a VPC subnet type public, VMs in the network bubble blue can talk to it. VMs in other VPCs, yellow and turquoise and whatever, can talk to it, and the outside world can talk to it as well. And this subnet this subnet gets a subnet from the IP block, external IP block, which, as I said multiple times, was defined at the installation of VCF, deployment of VCF. Okay, so if we recap, public subnet, everybody can talk to it. Private transit gateway, only your own VPC and other VPC can talk to it, but not the external world. And private subnet in your VPC, only stuff within your VPC can talk to it, but not other VPCs. Here we go. So if I deploy a two-tier application, what time is it? Yeah, oh, okay. If I deploy a two-tier application like web tier and DB tier, and let's say it's basic, I have just one VM web tier, one VM app tier, and an external clients want to talk to that new application web tier, DB tier, two-tier application. So first you create a VPC, VPC blue, and then you will create a subnet private because the app tier, you don't want people from the outside world to talk to the app tier. And you attach your VM to the VPC subnet app you just created above. And you create a VPC subnet public web. You attach the VM to it. And that's it. Clients can talk to web can talk to app, but client cannot talk to app. How do you do that? In this, I can do it live, but I have a recorded demo because I have some enhanced added pictures on it. I find it better. So I go on VPC as we've seen before live. I have my VPC now option. It's VCF 9, vCenter 9. And I just click on add VPC and let's call it VPC François. And here we go, François VPC. And I create a private block for any future private subnet in that VPC. I don't need to involve the network team. I can select whatever I want because that subnet will not be advertised in the physical world. So here we go. And my VPC François is created. Now I can create a subnet in it. So I will create my app subnet, and I wanted that subnet to be private. So perfect. And let's say I want 256 IPs in that subnet because I'll have plenty of VMs at some point. And I want the DHCP server. Here we go. And next, finish. And in a couple of seconds, I've done it live with you a couple of 30 minutes ago. So yeah. And I have my default gateway, my subnet, my default gateway, my DHCP server available in minutes. Now, I can visually see that in my topology. Now, if I go on my VM app called app, I can plug my VM app the very same way as before to that VPC subnet. You can see here I have VPC subnet and network. So that's new in VCF 9. Network, it's for the old port group VLAN if you still want to use that, or VPC, as I want now in this demo. And I pour on the app VM, and a couple of minutes later, boom, I have my IP in my subnet private for that app, which is 192.168.0.3, given by my DHCP server. And all that has been done without any network expertise. I mean, any vCenter admin can do that. You don't need to be expert on networking to do that, as you can see. Now I create my subnet public for my web. So web subnet. I want the access mode to be public. I don't know what public subnet is available. I just say I want 256 IPs for that new subnet. And I want a DHCP server. And here we go. Next. And a couple of seconds later, I have my web subnet created in my freshly created VPC François. And I can see that I have the subnet 10.1.1. So this is a subnet from an IP block that has been given by the admin, the network admin at the VCF installation. He gave a big block available for any future public subnet. Here we go, and I plug my VM into it. Here we go, done, and I will power on that VM, and a couple of minutes later, it's recorded. I will have my VM up and running with an IP address received by DHCP 10113, again from an IP block that was given by the network team at the beginning. And that new subnet, 10110/24, is now automatically advertised to the physical fabric. So the physical fabric knows, the world knows to reach that IP, it has to go to VPC, the VPC networking, and enter the VPC bubble and go to the VPC subnet web and to the web VM. So here we go. If I, oh, I'm just replaying the, okay, and the web tier is on. Okay, now if I go back to vCenter, I have, as we've seen a couple of times, this available in a nice topology. So visually, it's pretty easy to understand the network topology with my two switches, logical switches, and my logical router VPC gateway. And if I access my web IP, then I have access, and the web can talk to the DB 192.168.0.3. But if I go and try to access the app directly, it doesn't work because that subnet is not advertised to the physical world. So you don't even need a firewall. There is no IP reachability at all. But now, let's say I want to access my my VM, which is in a private subnet. So for this, we have the concept of external IP, and that's to give an IP public to my VM that has a private IP. And this IP comes from this big IP block that was given again at the VCF installation, and automatically VCF networking, and it can be consumed by vCenter, as you'll see in a minute. vCenter UI, vCenter API. I will have an IP public to my VM private. And now, through that external IP, I can reach my VM private with NAT, network address translation. Technically, that's the network configuration done. Yeah. So let's do that. I will create NAT or an external IP for my app VM that will configure NAT on my VPC gateway, and automatically clients will have access to the app through its external IP. So without any network tattoo and network expertise, I'm the vCenter admin, and I'll go to vCenter. I will go to external IP on my VPC François. I will assign a new external IP. Since I have only one VM, I don't have any selection to select the virtual machine because there is only one, and the VM has only one VNIC. So here we go. Now I have an external IP 10.102 available for external clients to talk to my private app VM. And now if I try to access it, my app VM from an external client, yes, it works again. I mean, it works. Now it works because I'm using its external IP. Here we go. So what did we do? We created a VPC. We created two networks, one public, one private. We're automatically creating a VPC. It made a VPC gateway, a logical router, and a default gateway for my two subnets. And without doing anything, the public subnet was advertised to the physical world. So the physical world has access to the web tier. does not have access to the app tier, but using or configuring an external IP one-to-one NAT, configuring an external IP for my private VM app. Now also, the clients have access to the app VM if they want to. And all that has been done with, I don't know, 20, 40 click, click, click directly from vCenter without any requirement of network expertise. I forgot to mention here, there is also DHCP server added into each of those subnets, but all that done very simply by the vCenter admin, which has no network expertise.
Dimitri, we have a question.
Yeah.
Do you access the internal IP and not the external IP for NAT?
Do you access the internal IP? Don't understand the question. The app has a private IP, and that private IP, because it's a private IP, is reachable only from VMs connected to VPC subnets. So the web tier can talk to the app tier, but the outside world, the client, cannot talk to the app tier, to the app VM real IP, because VCF or VCF networking or NSX did not advertise that whole subnet app to the physical world. So the physical world doesn't know how to reach that subnet. But adding an external IP for that VM, then yes, now the client receives the VM receives also a public IP address that is reachable by the outside world. And this external IP comes from the IP block external. I hope that answers the question. Okay. So now, how does the communication, how much time left? Yeah, still good. How much, if it's not clear, my answer, feel free to rephrase it. Now, I was pretty vague on how the communication works between my VPC, my logical network, and the external world. So those VPC, those network bubbles are fully inside ESX. That's completely decoupled from the physical fabric. The physical switches, the physical routers don't know anything about that network bubble. And now, as we discussed previously, if I have east-west communication, so communication within my bubble, then I have my VPC gateway, which is fully distributed. It's on all ESX. This router is on every single ESX, logical router. It's not a VM. It's running in kernel. It's not a VM. And it's distributed for scale and efficiency. But it's not a VM. It's running in kernel. It's really low impact in terms of resources. And I represented it only in ESX1, but again, it's everywhere. And when web wants to talk to DB, it goes to its default gateway, which is inside ESX1, its own ESX. Again, it's not a VM, it's a process in ESX. And then it's routed locally on the ESX1, and then encapsulated with the overlay, NSX overlay, starting at the ESX1 to the ESX2 IP, and then de-encapsulated and app1. So the physical fabric see only ESX1 IP talking to ESX2 IP and nothing to do with the web IP talking to app IP, as we discussed previously when we explained network virtualization. But how does people talk to web? Because you need communication at some point north-south for external clients to talk to internal applications. So we have something new in VCF 9.0, which is called Transit Gateway. And VPC is consuming that. So this VPC gateway, logical router, again, it's not a VM, has a default gateway, which is, again, a logical router, transit gateway. It's fully distributed. And this transit gateway has connectivity to the physical world. We'll see that in a minute. And connectivity to other VPCs. And there are two modes for the transit gateway. You can go with, for people familiar with NSX, with edge nodes and tier 0. So in this mode, you have here edge nodes are VMs. The VPC gateway is completely distributed. It's a kernel. It's a process. So it's not a VM. But here, yeah, you have edge node VMs hosting your transit gateway, hosting your tier 0, and your tier 0 is a logical router. Same thing as the transit gateway, same thing as the VPC gateway. So you have a first hop VPC gateway, default gateway, transit gateway, and it's the same transit gateway. It's for high availability and scale. That it's duplicated in multiple edge nodes. But yeah, next hop is transit gateway. Next hop is tier 0. So it's a logical router, but this one is special. It has an interface in the logical space and an interface in the physical space. So it has an interface on a physical VLAN pointing to a default gateway physical router, the Cisco, the Arista, the Dell, whatever you like, and running BGP. So this tier 0, and again, for high availability and scale, it's duplicated in multiple edge nodes VMs. That's how the north-south communication works and how the public subnets are advertised to the physical world. So when any new subnet public is created, the tier 0 will advertise via BGP. It's a standard dynamic routing protocol supported for more than 20 years on any network vendor. The physical router will learn about that new public subnet is available with the next hop, the tier 0s. And that's how the north-south communication and the advertisement of new subnets is done with the physical world. So that's
Dimitri,
one. Yeah.
we have a couple of questions on this
Yeah.
slide. So first one, is BGP the only option for interfacing with the physical network? Can that be eBGP or iBGP?
BGP, it's eBGP or iBGP, external, internal BGP. It's BGP, so eBGP, iBGP. Correct. Both are supported. Any other question? I see a question on MTU.
Yeah, a
Oh,
couple of more questions. So
yeah.
for encapsulated communication between
Yeah.
sites, L2 stretch, do you need to reduce the MTU of the internal network?
So as you can see here, when the web talks to the app, that traffic is encapsulated. So if the web, which 100% of the operating system, Linux, Ubuntu, Red Hat, Windows, name it, they have an MTU. The VMs, the operating system have an MTU of 1500. So here the packets will be encapsulated, which means this packet here received by the physical fabric is bigger than 1500. It will be around 100 bytes more. So that's why we ask for 1700 or more MTU on the physical fabric, which all physical vendors support for more than 20 years. But yes, you need an MTU on your physical fabric of more than 1500, so 1700 or more. And that's a requirement. And why we have this requirement, it's because we don't want fragmentation, which will kill the throughput of the overlay traffic. And by the way, large MTU, so that's a requirement for VCF networking, but it's also strongly, not a strict requirement, but strongly encouraged as well for other services in ESX. For vMotion, we strongly encouraged large MTU to make the vMotion faster. For vSAN, we also strongly encouraged larger MTU for the virtual storage for vSAN. So NSX, we also, so here we don't strongly encourage, it's a strict requirement, but there are already in vCenter, in NSX, a need for large MTU on not only for networking, but for all the other services as well.
Okay, perfect. So we have a couple more questions
Yeah,
real quick.
yeah,
So one, let me see if I can relay this correctly. So when web needs to access
yeah,
app,
yeah.
is there a mechanism to resolve names to
Oh,
IP in this
that's a good
scenario?
question. So IP connectivity, we talked about it, but some applications, or yeah, sometimes, yeah, a lot of times actually, I could argue, communication is not done um, by IP, but by DNS, by names. And in that case, uh, you will need, and it's possible, but you will need to link your VCF networking, your NSX, with your IPAM, so info blocks or other, I don't know what you have. And in that case, the VM IP will be given by your IPAM, like info blocks, for instance. So in that case, we cannot be the DHCP server, which it's okay. You can still use DHCP, but NSX will be only a DHCP relay. And here you can see it. When I create a new subnet, I do it live because I don't have a recording for that. And of course, in my lab, it's overwhelmed. It's taking forever. Usually, it's not that slow. I guess it's the demo effect. Come on. But,
Yeah, and I think in the interest of
uh,
time, Dimitri, we have a
yeah.
couple of more questions. So
So yeah, you have. I don't know what's going on with this. Well, my lab. I'll show you in a minute. But you do DHCP relay going to your info block, so you're good. Here we go. Gone. Yeah.
okay. So a couple more questions. Uh, what are the limitations of how many subnets can be created in the gateway, both transit and web app
As
subnets?
long as you have, there is a limit. I think it's 20,000 top of my head. So a lot, but you'll be more limited by your IP block. So you'll have to create more IP blocks to be available for new subnets.
Okay.
Yeah.
And one last one.
Yeah.
This is on load balancing. So does the load balancer in VCF only work with additional RV licenses? And what about the distributed firewall?
Uh, DHCP relay. That's for the previous question. Sorry for that. And it was slow because I've been disconnected because of timeout. But anyway, DHCP relay, that's what I wanted to show you to go to info blocks. Okay. And LB, oh, yeah, okay. So LB, you have, it's an add-on. So load balancing using AV, it's an add-on. And yeah, you need AV licensing. And DFW, so security, it's an add-on also, and you need VDefend license. That's why you have this asterisk. You see this asterisk here, add-on with separate licensing.
Okay. And I think the
Okay.
question is also, does the load balancer in VCF, does it need RV licenses to work, or are there use cases for
No.
the VCF load balancer?
Oh, so if you want load balancing of your VMs created from vCenter, you need AV. Now, if you have containers, like the demo I used with VCF automation where I have a load balancer, that's actually you don't need an add-on load balancer AVI license. As you can see I don't know if you remember, but in the application I created from VCF automation, uh, I created a test one. I don't know if you remember, and it created and yeah, it's because of running out of resources. So forget about that one. Again, it's a lab and I don't have enough resources. But the old one, LB, you can see I have this VIP and it's great. It's on my on my NSX, as you can see here, not AVI. So for VCF automation, you can use the native NSX LB, but for your VMs created from vCenter and so on and so forth, you have to use AVI. I hope that replies your question. Okay. Now back to this. So that's one way. The tier 0 going to transit gateway, going to VPC with the tier 0 advertising the new subnets via BGP. And there is this second option, which is there is no edge nodes at all. And that's cool for smaller deployments, or if you want to test network virtualization in a small environment. So here, if your physical fabric has a VLAN, like VLAN 10 and that big subnet, connected to all your ESX, so you don't have multiple racks not connected together in the same subnet. So you have a VLAN 10 with this subnet here connected to all your ESX. You can have your VPC gateway connected to your transit gateway going straight to the VLAN there and your physical router there. And in that case, you don't need edge nodes and tier 0 and BGP. So simpler, but not as flexible because your ESX must be all connected to the same subnet. You cannot have an L3 fabric for your ESX. If you have an L3 fabric for all your ESX, you have to go through the edge nodes and the tier 0. Okay. So now, how do you configure this mode DTGW? The new mode available in VCF 9. Tier 0 were available in previous releases. It's super simple. You can even do it from vCenter. You go on vCenter networking tab, and the very first time you go on network connectivity and you haven't configured any mode for your transit gateway. So at the very beginning, so you click on network connectivity. You don't choose centralized connectivity because this one is with the edge nodes and the tier 0. You select distributed connectivity and you validate the prerequisite, which is you have VLAN on all your ESX. You define the VLAN ID on your physical fabric where you have all your ESX connected with the default gateway of your physical router, 10.101/16. And you define your external IP block. So future VPC subnets public will come from 10.100/16 for any future VPC public subnet, and the private transit gateway IP block for any future VPC transit gateway private. It will come from that block. And that's it. Really, a couple of seconds later, it's done because this one does not require the deployment of edge nodes and configuration of BGP. So it's really a matter of seconds and not minutes, where centralized gateway requires, again, it's just once at the deployment of VCF, so it's not such a big deal to be minutes, even with a centralized gateway. But transit gateway, distributed transit gateway, it's really seconds. And from there, you can create your VPC, you can create your VPC subnets, all the other demos we did before. Okay, so few more minutes. Just to do a summary or history of the vCenter admin life. So in the old days, when you have the vSphere model, which is still available today, if you go with the vSphere model with DVPG VLAN, port group VLAN for your VMs, when you deploy a new application, you need to open a ticket for the network admin to create the VLAN in the physical fabric, to create the default gateway, the NAT, and so on and so forth. And then you can deploy attach your VMs to the DVPG VLAN, and yeah, it takes weeks as we discussed. Then we came 10 years ago, something like that, with the NSX model. And this one had a lot of success. and it has been implemented by thousands of customers. What is this one? The vCenter admin is the NSX admin. So you have in your data center vCenter and NSX, and the same persona, the same person, is the vCenter and the NSX admin, and he can create now in a fully autonomous way the network, the logical networks, the logical segment, the logical router tier 1, the logical router tier 0, create the BGP. But as you can see here, the vCenter admin, who is the NSX admin, has expertise in networking. It needs to understand subnets. It needs to understand BGP. It needs to understand routing. It needs to understand DHCP server. So lots of success this solution, but uh, only for customers where the vCenter persona admin has some network expertise.
Dimitri,
So many customers, yeah.
quick
Oh,
time
yeah,
check.
no, we have 5 minutes and we have the wrap up. Okay, so I forgot. I thought I was the last one. I speed up. Thank you. So it ended up with vCenter admin for the some customers. The vCenter admin is not the NSX admin, and so it did open a ticket, and the network admin was creating this in the logical space because it's better than the logical space because it's all centralized and so on and so forth. But still days because tickets. And now we have the VPC model where the vCenter admin can do everything in a very simple way, as we discussed. And I have a demo, but I won't do it because I'm running out of time. Where I wanted to show Power CLI, where instead of doing 20, 40 click, in one click using Power CLI, all this can be done. But there is already a blog where you can see exactly the same demo. So I'll let you Google VPC demo blog PowerShell, and you'll find it. Otherwise, contact me. Okay, I'll let you do the wrap up in the last 5 minutes. Sorry again, I
Yeah,
took too
and
much.
before the wrap up, we do have a question.
Mm,
So presumably we only need to ask network guys for an external internal access at our physical switches, and every other subnet, VLANs, etc. will be configured at the cloud level.
Yeah, it won't be VLAN, it will be overlay, but NSX overlay. But yes, you just ask the network team a block. And if you plan to have plenty of VPC public subnets, ask for a big block because it will come from that block. And any future VPC subnet overlay will take a slice of that big block they gave you at the beginning at the deployment of VCF. Yes,
Perfect.
correct.
Thank you. Okay, so I wanted to leave you with three key things to consider when you're thinking about networking for your VCF workloads. Number one, virtual networking is kind of the glue that makes the cloud operating model work. So the reason we introduced all the good things Dimitri talked about, right? So VPCs, transit gateways, the idea is to allow you to deploy applications faster in the VCF workload domain, scale those applications faster, and then make disaster recovery easier. Number two, we have also enhanced NSX and VCF networking to be non-disruptive to your existing environment. So the solution works with all the leading network fabrics that you might have running in your environment. If you followed some recent news from VMware, we announced the unified fabric architecture where we are building stronger partnerships and integrations with Cisco Nexus One, Sonic, and other switch fabric solutions. The idea is to make it easier to introduce and stretch the network fabric from end to end across your entire private cloud. So there will be more technical details on that announcement coming soon. Do reach out to your VMware team if you're interested in getting more details. And then number three, your cost efficiencies go up with VCF networking, right? So both on the server and CPU utilization as well as operational efficiency. Dimitri touched on how you can consolidate workloads onto fewer number of ESX hosts when using VCF networking. There's also EDP or enhanced data path mode, which improves network throughput, improves CPU utilization, which of course helps with both CapEx and OpEx TCO. Okay, and finally, if you're interested in diving deeper into some of the concepts Dimitri and I shared today, here's a quick snapshot of some key networking focused content at VMware Explore Las Vegas this year. These are available on the VMware Explore portal that you should have access to. And as you can see here, there's a broad spectrum of content, introductory overview sessions, more practitioner-oriented tutorials, breakout sessions, hands-on labs. So definitely make use of these resources. And with that, thank you so much for attending.
Thank you so much,
Uh,
Dimitri and Varun. That was perfect timing, actually. So thank you. And thank you to everyone who's joined us. As we mentioned at the beginning, the presentation's been recorded and your TAM will be able to make that available to you. If you had any follow-up questions, please do also follow up with your TAM. Please join us next month on January 15th, where we'll be looking at VCF Operations Management Pack Builder. We look forward to seeing you then. Thank you, everyone.